It is a possibility that Proxima B could become the next Earth. This question has stimulated interest and debate on a global scale. The search for a habitable planet beyond our solar system has long been a source of fascination for scientists. Proxima B, an exoplanet orbiting our closest neighboring star, Proxima Centauri, represents a particularly intriguing case within this broader search. Nevertheless, it remains unclear whether this distant world could support life as we know it. Alternatively, could it be that Proxima B is simply another rocky planet devoid of the conditions necessary for life? In this article, we will examine the current knowledge about Proxima B, the potential for extraterrestrial life, and the technology used to explore this fascinating exoplanet. Proxima B is situated at a distance of 4.2 light-years from Earth, revolving around its host star, Proxima Centauri. Discovered in 2016, Proxima B rapidly became a focal point for scientists, not only due to its proximity, but also because of its potential for being Earth-like. It is estimated to have a mass approximately 1.27 times that of Earth and to orbit within the so-called habitable zone of its star. This zone is defined as the region where temperatures are optimal for the existence of liquid water on a planet's surface, which is a prerequisite for the emergence of life as we know it. However, despite these promising characteristics, there are still many unanswered questions regarding the potential for Proxima B to support life. One of the most significant challenges to be faced in the study of Proxima B is the proximity of the planet to its parent star. In contrast to the Sun, Proxima Centauri is a red dwarf, a type of star that is significantly smaller and cooler than the Sun. Although this may initially appear to be a beneficial characteristic, there is a caveat. Proxima Centauri emits frequent and intense bursts of ultraviolet radiation, which is considerably more than what Earth receives from the Sun. Indeed, Proxima B is subjected to ultraviolet radiation that is hundreds of times more intense than that experienced by Earth. Such a level of radiation could potentially result in the gradual depletion of a planet's atmosphere, thereby creating an inhospitable environment for the establishment and sustenance of life. In the absence of a protective atmosphere, any water that may have existed on Proxima B's surface could be expected to evaporate, resulting in a planet that is devoid of any significant body of water and consequently appears to be arid and barren. Another potential issue is that Proxima B may be tidally locked. This implies that one side of the planet may perpetually face its star, experiencing perpetual daylight, while the other side remains in eternal darkness. If confirmed, this could result in significant temperature fluctuations on the planet's surface, with one side experiencing extreme heat and the other extreme cold. However, some scientists hypothesize that a tidally locked planet could still support life, particularly if there is a region between the hot and cold sides, known as the terminator zone, where temperatures could be more moderate and potentially conducive to life. However, in 2021, signals presumed to originate from Proxima Centauri generated considerable interest and enthusiasm. The question thus arises as to whether these signals were a sign of extraterrestrial life. While many were optimistic, the scientific community promptly advised against excessive optimism, suggesting that the signals could be merely reflections of earthly interference or naturally occurring phenomena. Nevertheless, the possibility that there may be other phenomena awaiting discovery continues to motivate research. The question thus arises as to how one might investigate a planet like Proxima B, situated at a distance of light years. The James Webb Space Telescope, JWST, represents one of the most powerful tools ever constructed by humanity for the study of the cosmos. The James Webb Space Telescope, JWST, launched in 2021, was designed with the specific purpose of observing infrared light, which is crucial for studying planets and stars that are distant or obscured by dust clouds. By analyzing the light emitted from Proxima B, scientists can gather data about its atmosphere, surface conditions, and even the possibility of water. Additionally, the JWST can detect artificial lights or patterns on the planet's surface, which could be an indicator of advanced civilizations. Though this remains speculative, the James Webb Space Telescope represents a significant advancement in astronomical research, enabling us to explore the universe with greater depth and clarity than ever before, including the planet Proxima B. While ground-based telescopes have their own merits, they are not without limitations. The light captured by these telescopes is distorted by the atmosphere of the Earth, which presents a challenge to the clarity of the images produced. By being situated above the atmosphere, space-based telescopes like the JWST are able to circumvent this interference, thereby facilitating the acquisition of images of distant planetary systems that are markedly more lucid and detailed. What insights has the JWST thus far provided regarding Proxima B? One of the primary objectives for the scientific community is to ascertain the existence of an atmosphere. The presence of an atmosphere is a prerequisite for the existence of life, as it plays a pivotal role in regulating a planet's climate, shielding it from harmful radiation, and creating the conditions conducive to the formation and persistence of water. The detection of an atmosphere on Proxima B would also increase the likelihood of the planet being capable of sustaining life. However, the results thus far remain inconclusive. Although some data indicate the possibility of an atmosphere on Proxima B, other studies have suggested that the planet's atmosphere may have been lost due to the intense radiation from its star. It should be noted, however, that Proxima B is not the only planet under observation. A multitude of other exoplanets are dispersed throughout the galaxy, and thus may also represent potential habitats for extraterrestrial life. As our technology advances, we are able to identify an increasing number of these worlds on an annual basis. Many of them are situated within the habitable zones of their respective stars. The discovery of Proxima B has reinvigorated the search for Earth-like planets, with scientists expressing optimism that a planet with conditions similar to those on Earth will eventually be found. The search for extraterrestrial life does not end with the discovery of Proxima B. Scientists are also investigating the possibility of life on moons, asteroids, and even the icy planets of our own solar system. For example, Europa, an icy moon orbiting Jupiter, has a subsurface ocean that could potentially harbor microbial life. Similarly, Saturn's moon Enceladus has been observed to have water vapor plumes, indicating the possibility of a hidden ocean beneath its icy shell. These findings have expanded our understanding of the potential locations for extraterrestrial life and demonstrate the necessity of extending our search beyond Earth-like planets. The question thus arises as to why the search for life on planets like Proxima B is of significance. Beyond satisfying our innate curiosity, the discovery of extraterrestrial life would have profound implications for humanity. Such a discovery would provide an answer to one of the oldest and most fundamental questions in human history. The question of whether we are alone in the universe remains one of the most profound and enduring questions in science. The discovery of even the simplest forms of life on another planet would have a profound impact on our understanding of biology, evolution, and the conditions necessary for life. Furthermore, it would prompt a re-evaluation of our place in the universe and give rise to new inquiries regarding the potential for intelligent life in other regions of the galaxy. Furthermore, the search for habitable planets has a practical aspect. As the global population expands and Earth's resources become increasingly scarce, many scientists have postulated that humanity may eventually require a new habitat to ensure its survival. While this remains a remote possibility, the concept of colonizing another planet has emerged as a prominent topic of debate. If we could identify a planet with conditions analogous to Earth, it could serve as a potential candidate for future human colonization. While Proxima B is unlikely to fulfill this role, the search for an Earth 2.0 continues. In the forthcoming period, a number of promising missions are scheduled to advance our investigation of Proxima B and other exoplanets. One such mission is the Habitable Exoplanet Observatory, HABEX, which is anticipated to be launched in the 2030s. HABEX will be capable of directly imaging exoplanets and searching for biosignatures, which are chemical indicators that may indicate the existence of life on these distant celestial bodies. Additionally, the LUVOIR, Large UV Optical Infrared Surveyor mission, is currently in development with the objective of conducting more detailed studies of exoplanets. These missions will facilitate a more profound comprehension of planetary systems, akin to that of Proxima B, thereby enabling a more definitive response to the enduring question of whether other planetary bodies in our universe may also support life. The question of whether we are alone in the universe remains unanswered. Meanwhile, scientists are engaged in ongoing analyses of data obtained from the James Webb Space Telescope and other observatories. With each new piece of information, our understanding of Proxima B and its potential to support life grows ever closer. While a definitive answer may take years to emerge, the journey to discover life beyond Earth represents one of the most exciting scientific endeavors of our time. As we direct our attention to the heavens and contemplate the unknown, one conclusion is irrefutable. The universe is immense, enigmatic, and brimming with potential, regardless of whether Proxima B proves to be a planet akin to Earth. Its discovery has inaugurated a new era in our quest to comprehend the cosmos. It is plausible that the next significant discovery may be imminent.